So Ben asked me to talk about Splunk because I am a Splunk guy, security engineering and all that. The SplunkTrust thing just means that I'm part of Splunk's MVP program. There's about 28 of us. So if you do go to a Splunk conference and you see guys wearing fezzes, those are real. We do wear them. So if you have a question about Splunk, ask any one of us. We all have our different areas of specialty because the thing about Splunk is it is a platform, not an app. So we all have different areas of knowledge, right? So just to give you an idea of my experience with it, I've been using it since about 2010. Done many different talks, so if you're using Splunk or you're adminning, you can go find these old talks, everything from the SSL configuration, which is quite the bear to use. We built this talk, me and my friend Dwayne, because Splunk's documentation on how to properly do all that SSL certificate replacement was so bad, and even Splunk's own people uses it. I did a bunch of alert script automation, some of that I'll talk about. Lookups, KV store. I've touched deployments that range from 5 gig a day to the one I'm at right now does 8 terabytes a day. And I work for a Splunk partner, contractor, does a lot of security work called Defense Point. So we're always hiring, so if you're looking for a job, let me know. So I want to tell this story. You know, everyone likes to talk about Splunk's expensive and all that, but let me tell you why I like it. A long time ago, I did retail loss prevention. I mean, to chase shoplifters. This was back in the day when we got a report, and my boss says, hey, here's this report. It comes in every month. It's all the credit card activity in our store. And it was on greenbar paper, had full address, name, card number. So yes, you can guess how old that was. I'm old. And he goes, here's how we handle that. He takes this thing, and he walks over to the file cabinet, he opens up the drawer, he drops it, and kicks it closed. No one ever reads it. It's this thick. Ironically, one of my best friends had gone to work as a mainframe programmer for the retail firm I was with. I called him up one day and said, what the hell is this query? This is ridiculous, we can't use it. Short is, we redefined the question because the way the criteria was worded, you could actually do any number of transactions for a certain dollar amount and never show the report. And you saw all the card activity company-wide. We redefined it so every store got its own report where it had any number of transactions total a certain dollar amount in terms of purchases, returns, and only if at least one of the transactions was in your store. So now the report that went to each store was this thick. First time that report ran, they caught like 5 employees doing credit card fraud, returns on their own credit cards, because it acted like payments. Stood out like a sore thumb. I never forgot that lesson of being able to redefine that question. And so when I started playing with Splunk in 2010 in logs, and I realized I could easily redefine my log questions and data questions. That's what I loved about it. And a lot of that comes from Splunk's dynamic schema, which I will talk about in a minute. So what is Splunk? Like I said, there's a lot of stuff in here. I try to put something in for everyone. So if you don't know Splunk knows, we're going to talk about that. If you're a red team guy, I got some stuff about how to go back and make your Splunk admins cry. And of course, your Splunk admin. And if you just want to use it at home, we'll talk about that too. It is time-based indexing of textual information. You hear about it as security logs, IT logs. It does not have to be. It can be any textual information. And please God, oh God, if you're logging and you're a developer, please use a full ISO timestamp with times up. Or even better, use UTC. Because it can be a real pain if people are logging and they're logging across multiple sites for redundancy. They don't put the time zone information, then they complain that they're searching for events and it looks like they're yesterday and they're really from the day because Splunk by default indexed with the time zone of the system that received it, having no idea of what time zone the logs were originally in. It's not a database. The basic nutshell structure is it's buckets of raw data with a indexed system attached to that bucket that says where in that raw data the events you're looking for are. So it's sort of almost in a way a flat text file system with some compression and other things. So the big thing about Splunk that's great above other tools who I will not name is that it does a late binding schema or dynamic schema or what we call search time extraction. So there's some fields that have to be done at index time, but for the most part you're setting up and saying I want this field from within the data. And it only happens when you search that particular piece of data, does it extract that and present it to you. And of course, it's a platform, not an app. So if you're really looking to scale this in your environment in a business, you need an FTE to make it really successful in the long run. You can start it out easy, as a test, but in the long run, you really need at least one guy who's going to carry the feed for this thing out, whoever. Generally about the architecture, runs on Windows fine, but you will generally have a better experience on Linux. You want details about that story? If you know Lauren, who runs B-Sides, go talk to her. I helped her through her Windows crisis to Linux conversion. But for the most part, if you start to read Splunk's documentation, you look at answers.com, answers.splunk.com, you look at people's tutorials, a lot of the debug commands, debug things, these all are so much easier and more well documented on Linux than they are on the Windows side. The configurations are the same, but you also can run into other limitations. I've seen Windows have problems with numbers of network connections coming in, if they have too big of an environment, there's all sorts of things. CPU, RAM, and disk IOPS, these are the critical things. So if you're using search heads, you're going to care more about CPU and RAM. Indexers are going to care more about RAM and IOPS with a good touch of CPU as well, because searches when they run in Splunk are being dispatched, and when they're running, they're sucking up a core. This is why, too, when you hear about people are like, oh, I want to make a real-time alert in Splunk, people like me take a baseball bat to them. Please, God, do not run real-time. You run real short windows of time so that the job can be dispatched, run, finish, and come back. If you run real-time, you're dedicating that CPU core, and it's gone, right? And so people can really kill your system with that. And that's where something like search clustering they have as an option. So you can have a single box, like I have Splunk running on my laptop, and it does it all, indexing, searching, and all that. But if I want to grow an environment, and especially as I get bigger and bigger and bigger, like I said, I have an 8 terabyte a day instance, to have enough search capacity for as many people that want to use it and run all sorts of alerts and things like that, it's nicer to have a cluster, because then those jobs will get dispatched and spread out over the cluster as CPUs and stuff are available, and you can just add more nodes. Indexing is a similar thing. Again, you can have a single indexer, but if it's down, you miss data. You can stripe across indexers without clustering, but if one particular node is down, the data that happens on that indexer is unavailable. Indexing clustering is basically Splunk sort of RAID, right? It replicates some of that data across those indexers. So the nature of the data going into Splunk, that index time versus search time. So things like the timestamp parsing, line breaking, whether it's a single line of text or whether it's a big multi-line event that has to be merged back and say this is one big event. Those things happen at index time. Search time are things like, there's an error code in my web logs and I want to be able to do a stats count by error code. So you're going to make like a regex and you're going to extract that field. That happens at search time. Really, really big multi-line files, like Java debug logs, are a nightmare because Splunk at some point has to go, by default, I'm going to break this thing up into several events, and you'll actually see, like if it breaks the event wrong, Splunk then has to try to find the timestamp at what it thinks is a new event line, and it finds some GUID that's like a number, and it thinks that's an epoch time, and it looks like it's 2 years ago. The other thing about getting data into Splunk is something called the Common Information Model. We'll talk about that in a second, and then data models. So with the Common Information Model, you're getting data in. You dump data into an index. Say I take my laptop logs and I shove it in index OS 10. And I want to look for SSH fails. Well, then I have to know something about the data. So I have to know it's got SSHD in it. Maybe it's just the word invalid, and that's all I find. So what the Common Information Model is it's a way of using consistent field names, some of them with consistent values. So you might take a field that's like in Cisco logs, it might be failed, and you really want failure in the action field, and you'll use lookup functionality of Splunk to clean that up. And by doing that, you abstract out having to know stuff about the original log data. So you institutionalize that guy. Like if you have one person in your team that knows that particular log really well, you get them to help sim it up and map things to the right fields. And then I can do a search like tag equal authentication, action equal failure, And then I can do stats values, unique users by the source IP, and then I get something like that where I go, these many users from the source IP. And actually that would then be any logs that were tagged as authentication. That could have been SSH, that could have been web application logs, any of that. So you make that easier to search, and that's also easier for people to learn that are just general Splunk users, right? There's actually an app that when you start getting into simming stuff, Splunk has a Splunk base, splunkbase.splunk.com. One of the apps you always install is this Splunk add-on for the common information model. And then you also then look for, like, let's say I want to get into Cisco log types. I look, is there a TA or technology add-on which says this log type I want to bring in, blue coat, whatever. It already has all the parsings. It's already, and it'll have a little mark as to whether it's SIM compliant. And you'll add that, and that'll help you parse your logs, and they'll all be SIM compliant. And then these easier searches work. And you'll also find that products like Splunk's enterprise security stuff use these SIM fields to do all its dashboarding and stuff. So you have to wire things up to this common information model to get the longest term best value out of Splunk. Doesn't mean you can't search it and just use it as a big graph. You certainly can. But you use this sort of common nomenclature to abstract out that stuff. So if you really want a simple example of how to do that, one day I got tired of answering that question. I made a blog post on just bringing in Minecraft data. You know, everyone's got kids here, kids next door, Minecraft. I just used a hacked, customized Minecraft thing. Bring in the logs, I did it all sim up, and then that tag authentication equal failure even gave me Minecraft indents. That's the documentation to the sim model. And this parsing gets applied to what are called source types. That's the type of log it is. Is it a Cisco ASA log? Is it a sys log? Is it a custom of log type? So you set these parsings up and you map it to that source type. So the general process for getting data into Splunk is you ingest it, you parse it to the SIM, and then you decide what events are important. And you do what's called event types. And event types in Splunk are nothing but little tiny search sections that say, search this index with this keyword and action equals success, and that's what I call a authentication success event. And then I tag it to what are called the data models, which are these. So there's like again, I had that link at the Splunk page. There's different models. They are not perfect, but they generally will tell you what tags to use, what standard values to use if you can control that value. And that way, all the data model stuff works, because things like ES, when you search huge volumes of data in Splunk, these data models can be what's called accelerated, meaning they, in essence, take that data, they reduce it down to just the fields that are in the data model, and it builds an extra copy of that that's indexed to just that field. So now a search that would have taken 20 minutes takes like 12 seconds. Now, the trade-off is disk space and how far you tell it to build that data model. It's a compromise between having fields extracted at index time, which is bigger on disk, but faster to search, versus search time, which is dynamic and you can change it at will anytime you want. Like say there's error code in your web logs that you never needed before. You make a regex to extract error code. And now, since it's retroactive search time, you can search all the data you have all the way back in time. Right? So, mapping these things to the data models.
George,
Bill, yes?
so ES has this, takes forever to index. Is there an incremental indexing pattern or capability?
ES?
Classic,
Oh, well, I mean, Splunk is indexing as fast as it come in.
is it re-indexing or is it indexing? Is it incremental indexing versus here's all my data, I'm index it all?
No, it's just in, it's in, right? Most of your field extractions happen in search time only when it goes to access the data that has the key, that matches your search, right? So it's not like it indexes every field. Now the data model does have to build if you do that,
Right.
and that sort of, you tell it how far back to build, and it constantly goes back over the data, and it sort of happens in the background, right? So how do you get data into Splunk? There's a bit of ways to do it. You have an agent called the universal forwarder. you can syslog it. Please God, if you syslog, do not follow the documentation and send it straight to Splunk. You can, but the problem is then you got a network port, it's on Splunk, and if you restart Splunk, you've got a gap in your data. You also can't load balance it. So if I make that input, it says listen on this port, on this particular indexer for syslog, and that indexer's down, I have no syslog. You're much better off spinning up our syslog ng, and then adding a universal forwarder to pick the files up off the hard drive. You can also do things like make your syslog configurations, write those out in a nice folder structure, like all the firewall logs go here. Maybe I reverse DNS, look up the name, so the host name is actually in the file path. Because I can tell the forwarder, here's the firewall logs of Cisco source type. Everything below this, pick it up, shove it in this index, the Cisco source type, so it's parsed right. And the host name happens to be the third position in the file path. So that means when they spin up a new firewall and start logging, as a Splunk admin, you don't have to retouch anything. The forwarder will just see it, pick it up, and start ingesting it. It'll all be right. Don't modify the format. If you do have to modify formats, whether it's syslog or we run into this with the web guys, we'll modify Apache logs a lot, and it breaks the association to the default Apache parsing types that Splunk already has, because they'll change the format up front and won't match the patterns anymore. So add it at the end of like your log format statement, and do it like this, where it's user key equal value. Because if you send something into Splunk with a key equal in something, excuse me, then Splunk will actually auto-extract it, and you don't even have to set up the parsing. So you make it self-lit. The last option that I'm very fond of is what's called HTTP event collector. You've heard talks earlier about webhooks and things, so you just take a big JSON blob and you post it in. And you can do it a lot. And the thing is too, universal forwarders, talking to Splunk indexers, there's ways to, it load balances across the indexers. It is not true load balancer friendly, and there's all sorts of other things that go with like big files, all that. HTTP event collector is an HTTP post and can ingest it. The other good thing about Splunk, they have a bunch of frameworks, modular inputs. Yes?
Sorry, I have a question as a stupid user, and you may cover this later. But if I'm just a user, is there a way for me to explore the data model that's been defined by the administrators?
Yeah, it's settings, data models are
Okay.
top in the menu.
And it's all there?
Yeah. Just don't de-accelerate it if you have permissions to do it, like if you're by default Splunking in because it didn't actually break up permissions, right? You don't want to de-accelerate it because if it's like a really big one, and you uncheck the cell. If you want to edit a data model, you have to unaccelerate it. Then you can edit it, and then when you check it back, it has to rebuild the whole thing. So don't just go change it, but you can inspect it and look at it.
Okay.
Most of the data models will be the default ones that come from that SIM SA, but there are applications that make their own data models. You can make them out of anything. And you can even go, like I will very often, if I'm ingesting a certain type of log from product, and they have some authentication events, but they also have a lot of network traffic events, I end up making searches that say, these match authentication events, that's one event type. And then these match network traffic events, that's another event type. And I tag those to the appropriate data model with the right field names, and tag equal network versus tag equal authentication, even though they're from the same source. And then the data models just pick it up and build it, and you can search over those a whole lot faster, right? But you can build what they call modular inputs. So if you've got Python code that talks to a REST API for something that you like, you can wrap that up, build it in the modular input, and now in the GUI and Splunk, you can just go, I need to add an input to this product, and its IP is this, and this user credentials are this, and now it starts pulling it in with your code, right? Modular alerts is the reverse of that. I really love modular alerts, because back in the day, I did these automation control, which I'll talk about in the next slide. But modular alerts now, you can again wrap them up, put them in the GUI, and say, take this and go flip on my hue bulbs and set them to this color. When the search runs and it matches, trigger this alert. And now they've added modular visualizations, so you can add all these fancy visualizations and funnel charts and all these things. Splunk is very Python heavy. You can obviously call whatever scripts and stuff you can through bash scripts and things like that. So if you're in the area and you're kind of learning Python, Tennessee is in February. It's a big Python little thing that happens in Nashville every year. They're usually the professional dev people. I go, they talk way over my head, but inevitably in like one talk, there'll be like one slide with 2 lines that I did in 50, and that makes the whole weekend worth it. So I encourage you to go to that. So let's talk about some use cases that gets a little bit more interesting here, because that's for the people who don't know Splunk at all, to give you a sense of how it works and what it does. I Splunk my laundry room. Point is, you can take in anything. I used to work for University of Alabama in Birmingham. I moved down there, got a work apartment. I found that the laundry room used a service called Laundry View, which a lot of college campuses use. And so I made my Raspberry Pi, scraped their mobile site for the status of the washers and dryers and all that. And I dumped that in Python, I dumped it in Splunk, tracked it for a couple of weeks and went, okay, now I know which days are the peak days. What's real interesting, you never know what you're gonna find. There are 2 types of people, the 1-to-1s and the 1-to-2s, or the 1-to-1s and the 2-to-1s. So I literally could see 2 washers stop and 1 dryer kick up, even though there was more than 1 free, because they were too cheap to use 2 dryers, or they threw their jeans in with their good clothes and they dried it, right? And then you would see 2 washers stop and 2 dryers kick on. So you never know what you can do, but the point is you can ingest anything into Splunk, as long as it's time-based and textual information. When I worked at campus, another thing I did is you can manipulate the data you get into Splunk. So our network guys did a really good job of putting a naming convention on our Wi-Fi. So mapping things on campus by location, because UAB's campus map was a city map. Static IPs, I knew where they resided. I was able to hack what at the time was the Google Maps app database, which was just a pickle of all the IP location information. And instead of putting it in Birmingham, I put all our IP ranges in their exact building codes. Because in our campus map, we had a embedded Google map that said building code to lat long. So I was able to fix that. But then when I had to tackle the Wi-Fi, well, that's not statically assigned. But I knew building code was in the host name field of the syslog data that I got. So I just told Splunk, slice off that first part with a little bit of regex, make that building code field. I made a lookup table with building code to lat long and applied that to all the Wi-Fi logs. It didn't matter what the logs said, as long as I knew something like my MAC address from my phone. Even if it was an error, it didn't matter, as long as it showed up. I then knew that error happened to this Wi-Fi at this location. So literally in the morning, you could watch me walk on campus, go to my office, go all the way back to coffee, go to a meeting, and go back to my office. And it came in real handy when we had a laptop theft ring. Because we get a call from the instructor, hey, my laptop's stolen out of my office. We're like, yeah, it fell off the Wi-Fi at this time. We saw it disappear from here. We saw it show up across the quad here. There's a public parking lot. We gave that to campus security. They're able to pull up campus. So you can manipulate a lot of that data in creative ways. I had automated our IPS control. It was scripted alerts at the time. Now it's modular alerts. So again, I looked at the REST API to our tipping point IPS. The IPS itself for tipping point only triggered SSH rules when it was a full session, but our snort could detect the half open scans. So I said, let's track the half open scans, make that a search, take those IPs, use the REST API on the tipping point when it fires, and tell the tipping point, you had quarantined this. And then it expired it out on its own via its own expiration rules on SSH scanning. So I didn't even have to manage it, but I was able to automate it. I moved to a hosting company where I could not block. But there's this wonderful thing called extended abuse reporting format. I updated my scripts. Again, most of this is in my Git repo, so you can always go get a lot of this. And literally made it alert, so search for these SSH fails beaten on my boxes. I say, launch this alert. It literally took the tabled results of this time range, this IP. It called back into Splunk via its own REST API because the abuse report format wanted a sample of 10 events. It would run that detailed search, say, give me just 10 events. It would attach it to an email template using Mako. and send out the abuse report. And then people like AT&T, GoDaddy, and all that actually automate their abuse channels to watch for those XR things, and then that would trigger all the stuff to go burn down that infrastructure that was abusing me. Right? NetFlow, I'll talk about that in detail in a little bit. We heard a good talk from Jason again on NetFlow yesterday. If you're getting DNS logs, anyone here familiar with Levenstein? So Levenstein's there is an app on Splunk based to that. It's basically a distance calculation between two strings. So it's good for looking for lookalike domains. So if it's like two places off, because it's a 0 instead of an up, that's 1. Right? If that's the only thing that changes the distance, 1. So you can search your DNS logs, pipe it to Levenstein, get those values, and then you can make alerts and stuff based on that thing. And getting this kind of data into Splunk makes it handy. And if you're really crazy, yes, you can actually send logs from a Raspberry Pi over Tor. I did a blog post on that a while ago. Basically, there's a Raspberry Pi forwarder. I think I've got the link further down the slides, where you can throw that forwarder agent on a Pi. And then I just wrapped it in Tor and sent it back. So theoretically, you might could drop a Pi wherever you want. No one would never know where the logs actually went, right? So we heard a lot yesterday about phishing. We've heard today about phishing. And everyone likes to think, oh my God, it's so sophisticated. Let me tell you, it isn't. This was from back when I did that. Literally, I had just built that IDS automation the week before when this happened. We had what we call my Nigerian BFFs. They would phish our employees, students, and they would get their credentials, and they would come back into OWA Outlook Web Access. They would set up inbox rules to throw away any emails from the direct deposit system. And they would then use their credentials to log into our direct deposit system, because of course the university had to make that directly exposed for everyone's convenience at the time. It's since been improved. To log in from anywhere, and then they would change their direct deposit, and then their paycheck would just go bye-bye. And so that would be what it looked like. And it's an educational university. Yeah, real sophisticated. A bunch of kids with textbooks on their head. They didn't ask them to fill out this form, and lo and behold, they did. So the moral of that story is you can take those logs from anything. Like in this case, it was Exchange logs. I get that IP information. I actually talked to other universities who are also dealing with this problem and said, anyone got a list? Because a lot of this traffic's coming from really cheap hosting providers. Anyone got a list of that? And someone had an initial list. I made that a lookup table. I applied that to the logs. I set up alerting that watched for it. And said, anytime you see these weird logins, especially multiple countries for the same user, which is that bottom example, because when your user's country and all number of countries in a day looks like a roll of lifesavers that's been cut open, that's bad. Then that's these guys coming in. And so I coupled that with my automation, which I glued together with some Python and a REST API. And so using Splunk as the core, I literally had an always-on analyst watching this particular problem. And they would log in, it'd slam the door in their face, block them for a while, they would back off, and they come back in. We'd even feed like bogus credentials to their phishing form and smoke test it, and I'd set up watch just for that user because I knew there was no way that one was bad or good because it didn't exist. And I would just have it auto block that one for sure. And then I would just flip this on when we were dealing with that outbreak. And then the other advantage too is we were already getting web logs for the direct pay system that handled all that web interfacing in the Splunk. But at the time, I didn't know what I was looking for. So I just went to our web dev team and said, what's the URL look like for the direct deposit form page? Now I knew what to look like. I could mash it up against the Exchange log. So if I saw this login activity from Exchange and I saw a hit on the direct deposit, send an alert right then and we deal with it. So that's one advantage of Splunk is you can take these things and mash them together. So NetFlow, real quick, I'll touch on this. Won't get into detail. It's a real good paper. It's older about how to get NetFlow into Splunk. The problem with that is it's really big. NetFlow is always huge. It will destroy your license. So if you're not working someplace like where I have, where they have the unlimited license agreement, where they write a huge check every year, you need to come up with another way. So at the university, what we did is we collected NetFlow. We made a script. In our case, it was some Python. And we ran it across the NetFlow files every 15 minutes And we boiled it down like a poor man's Bloom filter. We just took all distinct IP, source or dest, in that time frame, single column list, very small file, and I automatically ingested that into Splunk. So even though I had a much more limited license and I couldn't take all the netflow in, I could still search for a given IP. And if in Splunk, just wide open, and if I saw it nowhere but the netflow, I knew what time it started showing up, and then I could go run nfdump and look at the details. And then what I did from there is I set up a folder. I made the forwarder watch it. I already knew that it came in with these columns and stuff. So I set up the parsing. And that way, if I ran nfdump, redirected to text file into that folder, it would automatically be picked up, sucked into Splunk, a much more limited data set. But then I could mash it up against all the other logs, mail, firewall, whatever, and be able to put those things together. So if you saw Jason's talk yesterday, he talked more about RW filter and RW cut. And so you could probably use some of that to do it. And I noticed, although I haven't explored it, the RW cut looked like it had some sort of Python plugin mechanism. So, heck, Splunk has a new input type called HTTP event collector. I wrote a Python class, if you're into Python. I'll talk a little bit more about that in a bit, but basically you could send that data to heck using Python as a plugin for RW cut, rather than actually having to use the forwarder to do it. So some gotchas about Splunk. That's going to vary based on the scale. Don't make overly broad event types in SIM. So like I mentioned Lauren, I went to help her, and someone had taken all their antivirus logs and just tagged them as malware. So in her dashboards, when she was searching for bad malware hits, she had a whole bunch of unknown, because every log event coming in from Sophos or whatever it was tagged to the model. But it wasn't all malware detected events, so it was missing the source, it was missing the signature name, which host triggered it. Some of it was just download events. So it was garbage, it was gumming it up. So when you make your event types and tag them to the models, actually go for those high value events that are actually what you're looking for. Splunk secret in clusters. There's a Splunk secret key that has to do with how it encodes passwords in the config files. If you're making a cluster, my recommendation is you set up your cluster master, you take that key, and you copy it to each instance of Splunk before you start it up so they all share the same key. Because that way, if you send a config that has a password, you can send it already encrypted to all of them, rather than letting each one encrypt it with its own key, and it's just a little cleaner. Geodatabase. So Splunk has built into it the MaxMind database, the free one, which only gets updated when you update your Splunk install. So there is a config I actually have in my Git repo, a little TA just for this. That is an L script. It's not really made for Windows. If you're running Windows, you might have to modify it. But basically, just does a wget every month, or curls if you uncomment the other one because your system supports it. Grabs the updated database, puts it in location, and uses the right Splunk config to say, look at this copy instead of your internal copy. And then that way your geo information stays up to date, because if you're doing stats count by country, today your Splunk is a year and a half old. You're assuming you're getting good results. You're probably missing a lot of stuff that would be China, right? Because the database is so out of whack. Lookups in Splunk, they will be held in memory most of the time. There is a limit called maximum table size. If it goes over that limit, Splunk creates a little mini index version of that lookup file. On disk, there is a bug that has not been fixed, that if you're in an index cluster and you send a search to the index cluster and it goes over maximum table size, sometimes, you never know when, every time that lands on disk, the indexer will go, hey, I need to create this local copy that's indexed. That's a single threaded process, and it only does like 2 megabytes a second. So suddenly what happens is if it does it the first time, and that's the way behavior is, it lands on the disk, it does it once, it's good. The next search comes in and references the same thing, it just uses the already done one. The bug is sometimes it thinks it needs to keep doing it over and over again, and suddenly every search takes like 2 minutes longer than it ever would have before. So if you see your search is slowing down and you're referencing a lookup table that's really big, if your Splunk admitted in the room, then you need to be aware of that. You may have to up that memory limit. So not changing defaults makes your pen testers happy. Here's a fun one. By default, when you install the universal forwarder, most people install it, it's running as roots. The local admin password for that Splunk instance is admin and change me. Most people don't think about this because it's the forwarder. It's not what people are logging into Splunk. The problem is the REST API for Splunk is still active on a universal forwarder. It will only accept authentication of the admin account by default if you've changed the password from another. In other words, if the admin changed me and you try to hit it from another box, it will say authentication failed. If you do it from the local box, and he sees where this is going, it accepts it. So what happened is one of our pen testers is on an engagement, comes in our Splunk channel and says, hey, I'm on this engagement, I landed on this box, I'm standard user, I see the Splunk forwarder running. I know it's running as root. What can I do with that? Me and Dwayne had thought about this, but never really messed with it. We're like, well, the REST API, if it's still running as root, they probably didn't change anything else. It's probably still admin change me. Try this curl statement. That worked? Yep, okay. Admin change me still works. So here are the two curl statements to tell the forwarder, because forwarders in Splunk, there's a role called deployment server, so that you can set up a deployment server role of Splunk that hands out application configurations. That can include scripts and all sorts of stuff, right? So in essence, we just said, spin up your own DS on your laptop, execute these two commands. It will tell the forwarder to point to your laptop, and then restart. And when it phones home, it will take the app you send it, which has a reverse shell, and now you have a reverse shell on this root. He then proceeded to own their entire infrastructure all the way up in their code repos and get their Amazon private keys. A friend of ours wrote just a quick TA reverse shell there, so you can see that as an example. So you're the blue team and you're a Splunk guy, go back, and you can just run this little command as an example to go look to see if you've got admin change be active on any of your boxes. Real quick, just a curl, gets you back, and you can see if your auth fails, your auth successes, if it works. Now this is more for the servers, because again, the universal forwarders, if you haven't changed it, won't accept the auth from off box. But in case you spun up a bunch of servers and forgot to change it, this will catch that, right? So, real good information on that. One of the guys that works for me did this talk at Conf. That's his GitHub with all his scripts. There's stuff there for Windows 2. Also his slide deck from Conf and all that. These are all the things we do to harden our environment for Splunk. So you can go to that. That TA about the geo database updating, that's there. And if you want to see the stuff about the SSL, changing all the certs, because there's many different levels to the certs. There's Splunk to Splunk. There's the users to the web page. Forwarders actually talking back to the indexers. Our whole talk, all our slides, all that are there in that virtual conf session, which is basically recorded WebEx type things where we presented the updated talks from the conference earlier in the year, recorded it, and of course the slides. So where does that leave you if you don't use this at work? You're not going to use it in a work environment, you just want to play with it. Grab Splunk. You can get a free developer license, it's 10 gig per day from Splunk, just by going to dev.splunk.com. If you are a Splunk customer, they've changed the rules and you can get a 50. So if you work for someone in Splunk and you have a login for Splunk, you can actually ask for 50 gig per day. If it's just you at home, get a 10. There's the link to the forwarder for the Raspberry Pi. It is dated, but it does work. There's other apps. So if you saw the Alexa talk from earlier, it's really cool. There's an Alexa app that one of the Splunk devs wrote because he set up an Echo. He Splunks the data from his car and he can ask Alexa all the data about his car. But HTTP collector, I love this thing. It sends in by payload. You can start combining it with other tools. So again, if you're doing homemaker projects or you're a security guy, Shodan, JSON payloads returned from Shodan API calls, go straight into Splunk. They're great. Maybe they're not SIMs, but they're still highly useful. And DNS Recon. So let's look at Carlos Perez's DNS Recon. You can just grab it, and then You can use my HTTP event collector class if you don't want to try to do your own stuff with Python requests and all that to hit their API. Makes it really easy. And what that looks like is, see if I can. So, yeah, let's see here. I just downloaded it. Splunk. I put a keyword and I don't search it. There we go. So I just added just a few lines here, these right here, where I pull in my class right there. I instantiate a collector connection. I tell it the key, because when you set up, it's all in the docs, that's why I didn't want to go into this stuff, but when you set up HTTP collector, you get an auth token. It's meant to be, it's very load balancer friendly. You don't have to have user credentials. It's only for putting data in, so it doesn't do anything with the REST API, it's just for ingestion. They designed it all that way on purpose. And you tell it where the Splunk server is, in this case localhost. I just sort of make a little payload object. I say what index it's going to be, what source type to call it, what source to call it, and what host I want to say it came from. And then down here, I did nothing but add these little lines right here. Since he already had an output for JSON and DNS recon, I just said loop through it and post it to Splunk. Boom, done. I've just modified DNS recon, a tool I already use to send the JSON payloads into Splunk, and now I can throw it up against other data. If I'm a pen tester, I pull other stuff in and do this. But the point is, you do this with your own code. You know, if you're using a Raspberry Pi, you got your kids, you're logging things, you're pushing buttons, you could be using Splunk and pulling all that stuff in. And then Splunk, again, has those modular alerts that you can tie to if this, then that's, with hue bulbs, whatever. If you get in really big, crazy JSON payloads, Splunk has this spath command that you can use when you're building your searches to actually parse a lot of real data out. So again, that's like me running it. Once I've modified it on my own domain, that's what the output looked like. And then I can search it in Splunk, and there's each record within Splunk. And then I could do like a stats count. In this case, it was a DNS recon stats count by target and address, and then I did an IP location, so I could see, like, you know, some of these records are pointing at Google, some of them are pointing at GoDaddy, whatever, and like that. So you can, even when you leave here, if you're not doing Splunk professionally, you can use it at home, play with it, learn it, add it to your tool set for your career, whatever. And that's pretty much the whole potpourri of trying to do something for everybody. Questions? Yes?
So what advantages are there on Splunk over, say, Elk?
They operate differently. I'm not an Elk expert, but it probably takes a lot to get Elk up and running and maintain it. There's all the build things that go with that. So from a corporate standpoint, you know, if I'm the corporation I'm using it, I'm looking at it as how sustainable is it for my tool set? If it becomes ingrained and my developers are pulling in logs and my security is depending on logs and my compliance depends on that, I don't want one guy who knew Elk and stood it up to do it, right? I'm not saying there's anything wrong with Elk, I'm just saying it's different reasons for different things. You can certainly do things with Elk and all that. And there is such a huge community base. You can go to docs.splunk.com, and in the top right is a pull down for the versions. So you can see all the version changes, the documentations of the different versions of Splunk over time. And you can see that as a company, Splunk does not rest on its laurels. They add these new frameworks, new visualizations, new input types. They're constantly evolving those features for that money that you are spending, right? What else? Yeah.
There's a lot of nice plugins for Splunk as well.
Yep.
So we've got certain logs that we see that actually send them to our Slack instance.
Yep, I use Slack alerts all the time.
By the way, cron tab on the server chain that probably was deployed. Here's the diff. You should go look and make sure it's
Yeah, we use the we use the LDAP TA. We pull from my customer centralized LDAP. There's an LDAP group just for who's Splunk admin, And then we put that to a lookup, and then I have a search that looks for any SSH activity to any of my Splunk servers, and say if that user's identity is not in the LDAP lookup as a Splunk admin, make a notable event in our, because we do use Splunk Enterprise Security, the paid product, but I also make it drop an event in our Slack, and then I'll go hit our red team guy and say, server 5 says hello, what are you doing? You know, so yeah, using like the Slack integrations, posting the if this and that, make the lights flip red because something's happening in the SOC. You can do all that, and like I said too, in Splunk base, if you're going to ingest a given log type, look to see if there's already an app that does all that parsing for you. Don't reinvent that wheel, right? That's a good thing to do too if you're looking at evaluating Splunk in your environment. Look at what logs you already get or what you have in your sync. Go to Splunk base. Do they have TAs for those? How old are they? Are they SIM compliant? That'll give you a good idea of how easy implementing certain things in your environment is going to be. The advantage is you can always cook your own because it's very flexible. Everything in Splunk is a text config file. You can git repo them and do version change. You can do all sorts of creative things. So there's nothing hidden there. You can look at how other people, you will have to get good at regex if you want to get good at building your own extractions and stuff. But yeah, you can do all sorts of crazy stuff. What else? Well, thanks.